Hi, this is Mark Malberg with Verified Technologies. The BrakeView system isn't just for measuring brake rotor runouts and thickness variations. In fact, it can be used to measure many other features like roundness, flatness, and even harmonics. So in this video, we're going to take a look at roundness and flatness measurement, and it all begins with the brake screen. BrakeView is indeed a brake measuring system, so our first screen is the brake rotor, but let's go to the menu and choose roundness and flatness. From here we've got a new display. This will be a polar display for our measurements. But before we go there, I want to exit out of the roundness screen, go back to the main brake screen and the main menu where we can set up our photo sensor. We need to make sure that our photo sensor is sensing 1 pulse per revolution in roundness, just like we did for brakes. So we'll go through here and we'll set up our threshold, and once that's set, it does remain throughout all of the BrakeView software. We can exit out of that and go back to the main screen. Once again, hit the menu and we are back to roundness and flatness. Before making our roundness measurement, we need to tell the BrakeView system the kind of measurement we want to make. So the roundness settings screen gives us the ability to configure these kinds of measurements. You'll notice the roundness settings screen has positions for 2 different probes, our yellow probe and our blue probe at the top. And those probes can be set for roundness, flatness, or they can be turned off or put in a not used mode. In this case, we'll choose roundness with the yellow probe only. A roundness measurement can occur on an inside or an outside of a part. We'll choose outside in this case. And then one last thing we need to configure is we need to tell BrakeView where the probe is located. So to do that, we're going to put the photo sensor over the tape so it's currently firing, and then we're going to look at our measurement setup and determine where is the measuring probe. In this case, the measuring probe is at about 5 o'clock when viewed from above. So I'm going to go over to the probe position adjustment and move this probe position until the screen shows that 5 o'clock position. Now as I move this, you'll see the angle changing, as well as you'll see a little yellow pointer moving. And this yellow pointer gives us an idea of where the probe sits in space. This is important because in a few minutes we're going to have a plot on the screen, and we'd like to know where the screen plot features match the actual component we measured. And just one reminder here, it doesn't matter where the photo sensor is, we are telling the BrakeView system where the measuring probe is. This way it knows where the data collection begins. The last measurement setup item is the actual type of rotation that we're going to use. If you recall in our brake rotor measuring video, we can hand spin a component and we would spin 5 rotations and use BrakeView's speed compensation mathematics. Another type of measurement is a motorized measurement where we have constant speed and BrakeView only needs 1 rotation. The same is true in roundness measurement. We can choose 5 rotations, which will use speed compensation, or 1 rotation, which is a motorized measurement. And we can choose either clockwise or counterclockwise measurements. You might also notice that the direction of measurement is shown on the probe position indicator. So for this measurement, let's choose 5 counterclockwise rotations. So now that we're set up, we can press the OK button where we're taken back to the roundness screen, and we need to move our probe into measuring range. And all we have to do now is rotate the part and hit the record button. Since we're measuring 5 rotations, the progress bar will show us how we're doing in terms of the measurement, and we now have our measured data. In this case, the data isn't showing us much because our scale is too big. So let's go in and shrink the scale down, making a smaller number per divisions, and we can now see the eccentric data set. This is a plot of the actual run out of the probe, but for roundness it might be interesting just to see the roundness and not see that center shift. So let's choose the center the plots option, and now we can actually see the shape of our part. When we see a plot like this, it's useful to be able to relate the bumps on the plot to the actual positions of the part. One way to check our orientation is to actually put a piece of tape on the part. I've rotated the brake rotor so the white tape is underneath the photo sensor. This is the 0 position. And I'm going to put a piece of green tape at 6 o'clock. So in the 6 o'clock position we should see a bump, and if we have a Gaussian filter of 50 UPR or perhaps no filter at all, we should be able to see this bump as it won't be filtered out. And sure enough, here's our measured data. And if we rotate our part now so that the photo sensor is on the tape, the part orientation and the location of the tape matches the plot exactly. So there you have a bit of an introduction to roundness. Flatness works exactly the same way. If you have any questions on either, you can always find us at BrakeView.com. Thanks.